plus 5 oxidation number. At the same time, if you are seeing here, this is minus 1. So plus 5 to minus. So this is decreasing oxidation number. So here reduction taking place. This is decomposition reaction. Next we are going to see displacement reaction. Third one is what? Displacement reaction. Decomposition is splitting of compound. What is the meaning of displacement? The redox reaction which on ion or atom in a compound is replaced by another atom, another element, is known as displacement reaction. It is also classified into two: metal displacement as well as a non-metal displacement. So metal displacement, if you are taking, suppose we can see one example for this. See here this picture, here two diagram here. So in this two diagram, zinc metal strip, this is zinc metal strip which is placed in aqueous copper sulfate solution. So this is aqueous copper sulfate solution. Here zinc metal, the zinc metal is placed in aqueous copper sulfate solution. So what happened? Intensity of blue color of the solution slowly. Here what's the color? Copper sulfate, actually blue color, no? It is intensity of the color slowly reduced. Slowly reduced, automatically it becomes colorless. The colorless, finally the color should be disappeared. So slowly reduced and it is disappeared, the color. So it becomes colorless compound. It becomes colorless. So what happened here? So the zinc metal strip became coated with the brownish metallic copper. See here, the zinc metal is coated with the brownish metallic copper, and this is due to the following metal displacement reaction. So the zinc rod placed the copper sulfate is placed on the zinc rod. Now it is colorless. After some time the transformation of electrons takes place here. So this rod will become brownish color. So copper sulfate, here zinc. The zinc rod is placed in a copper sulfate. Zinc rod is placed in a copper sulfate solution. This is releases 2 plus ion. This is releases Cu2 plus, becomes Cu2 plus. This Cu2 plus is accepted by zinc. So that is why the coating is on the zinc rod. So copper sulfate here, this is plus 2 oxidation state, and zinc is 0 oxidation state. So the copper is plus 2. At the same time here CuO. What happened here? It is Cu2 plus. At the same time copper here, it is 2 plus, means reduction takes place. So reduction, reduce. The oxidation number decreased, no? So oxidation number is decreased. Zinc is 0 oxidation state. It is accepting 2 electron from copper. Here plus 2 oxidation number. So 0 to plus 2, increasing oxidation number. So increasing oxidation number is what happened here. Oxidation takes place. This is displacement reactions for metal. And one more thing, non-metal displacement, non-metal. So here zinc as well as HCl is placed here. This is 0. Again this is hydrogen is plus 1 oxidation number. If you are seeing here, zinc becomes zinc 2 plus 2 oxidation number, and H is plus 1 as well as when it becomes 0. What happened here? 0 to 2. Here oxidation number increased. So oxidation takes place. At the same time here plus 1 becomes 0, decrease in oxidation number. Oxidation number decreases. So here reduction takes place here. This is known as metal displacement reaction. Next we are going to see competitive electron transfer reaction. Competitive electron reaction. So oxidation number in terms of transfer of electron we are taking oxidation number. So redox takes place in terms of oxidation number. Here the competitive electron transfer is nothing else. Suppose we can see one example here. The copper rod is immersed in silver nitrate solution. Copper rod is immersed in silver nitrate solution in a beaker. After some time the solution turns blue in color. Here colorless, it turns into blue in color. So what happened here? This is due to the copper becomes copper 2 plus. It means Ce2 plus. So the copper replaces silver rod. It becomes silver from silver nitrate compound. Here this is indicate that the copper has a tendency to release Ce2 plus and silver has a tendency to accept electron, isn't it? Here the electron transformation, which is donating electron, which is accepting electron. Here the copper is a donor of electron and the Ag is the acceptor of electron. That is why the color will be changes here. The colorless will become copper. So copper, it is a +1 oxidation state for silver here. Copper becomes copper 2+. So here increased oxidation number, here oxidation takes place. At the same time, here +1 oxidation number, here silver accepting, so it's silver metal. So here decrease in oxidation number decreased, so reduction takes place. This is combo to electron transfer of electron. Mostly the zinc is greater electron accepting, electron donating. Actually silver, the electron releasing tendency is following order. Zinc is more electron donating and then copper and then silver. It is a donor of electron. One more compound is dispropionation reaction. Dispropionation reaction is what? It is auto-redox reaction. Auto means automatically, simultaneously the reaction will be takes place here. So the same compound can undergo both oxidation as well as reduction in such reaction simultaneously. The such reaction, the oxidation state of one and the same element both increased as well as decreased. Automatically the reaction simultaneously takes place is known as dispropionation reaction. For example, we can see hydrogen peroxide compound will be gives water molecule as well as oxygen here. This is -1 oxidation number, this is -2 oxidation number. So at the same time, if you are seeing here -1, so automatically this is -2. So here reduction takes place. At the same time, if you are seeing here hydrogen, so this is 0 oxidation. If you are seeing here the same compound, here 0. So -1 to 0 means automatically oxidation, increased automatically oxidation. So oxidation as well as reduction takes place. So this is known as dispropionation reaction. So in this compound we are seeing what are the types of reaction: combination reaction, decomposition reaction, displacement reaction, metal displacement reaction, and dispropionation reaction, and then commutative electron transfer reaction. Thank you students, we will see you next class.